The question number 9 is cos 3 pi by 2 plus x times cos 2 pi plus x times cot 3 pi by 2 minus x plus cot 2 pi plus x. This expression we have to prove equal to 1. So this is the question. First, cos of any angle with respect to 3 pi by 2. 3 pi by 2 is the negative y-axis. Y-axis is the change line. X-axis is the no change line. So any angle with respect to pi by 2 or 3 pi by 2 means odd multiples of pi by 2. That t ratio gets converted to the other t ratio means cos sine interconvertible like that. So cos of 3 pi by 2 plus x. Where is this angle? This angle lies in fourth quadrant. In fourth quadrant, cos of an angle is positive. So this remains positive, but this gets converted to sine. So sine of x. With respect to this angle, cos gets converted, but cos of this angle lies in fourth quadrant, and in fourth quadrant cos and secant are positive. Next, cos 2 pi plus x. 2 pi is the x-axis. Along x-axis, all trigonometric ratios remain as it is. They don't change. So cos remains cos of x. But where is this angle? This angle is in the first quadrant. And all trigonometric ratios in the first quadrant are positive. So cos 2 pi plus x is cos x times cot 3 pi by 2. This is the change line. So cot of 3 pi by 2 minus. So change line. First we respond to this. So cot becomes tan. So cot of this angle is 3 pi by 2 minus x. If this is a 3 pi by 2, this one, minus x means it is in the third quadrant. In third quadrant, tan and cot are positive. So cot 3 pi by 2 minus x is cot gets converted to tan, and it is tan x, and cot tan are positive, plus cot of 2 pi plus x. 2 pi plus x is the first quadrant angle. In first quadrant, all t ratios are positive. So cot is positive. With respect to 2 pi, no change. So cot remains cot. It is cot of x. Now, sine and cos is in simple form. So they stay like that. So sine x, cos x. Tan can be written as sine by cos. Cot can be written as cos by sine. We'll take LCM of this part of the expression. LCM of denominator is cos x times sin x. Numerator is sin square theta plus cos square theta, which turns 1. Now this cancels and we land at 1, which is going to be the RHS. By the way, we started from LHS. So from LHS expression, this is LHS. This next step is this. From LHS expression, we came to 1. 1 is RHS. Question number 10. Sin n plus 1x times sin n plus 2x plus cos n plus 1x times cos n plus 2x is equal to cos x. Since left hand side is complex, we will start from left hand side and we will reach the right hand side. So this is the expression. But how does this expression look like? You see, this is the product form and this is the product form in left hand side. Which trigonometric identity this is resembling with? This is very much like cos A into cos B plus sin A into sin B. So what is cos A, cos B plus sin A, sin B. Cos A cos B plus sin A sin B is cos of A minus B. So comparing this with the left hand side, A is n plus 1x and B is n plus 2x. Now we begin from left hand side. Left hand side, this is the expansion for this. So we will directly write that it is going to be cos of A, means what? N plus 1x, which I am writing it as nx plus x, minus B. B is n plus 2x, but negative sign, two terms are there, so both the term symbol will change, sign will change. So nx plus 2x. So negative nx, negative 2x. Nx cancels. We are left with x minus 2x. So it is cos of minus x. Cos is even function. So cos of negative x is going to be cos of x only, and this happens to be the right hand side. Question number 11. Prove that cos 3 pi by 4 plus x minus cos 3 pi by 4 minus x is negative root 2 sin x. So from left hand side, which appears to be more complex, we have to go to right hand side. Now this is not a convertible t ratio, means it is not cos 3 pi by 2 plus x. It is 3 pi by 4. So the left hand side should be compared with some trigonometric identity, and it is matching with cos C minus cos D. What identity we know related to cos C minus cos D? Cos C minus cos D is a negative 2 times sine of C plus D by 2 times sine C minus D by 2. So we will begin from left hand side, but before that, what is a C? C is 3 pi by 4 plus x. And what is a D? D is 3 pi by 4 minus x. This is a C, this is a D. What we are going to write? This one in form of this. So I am writing the next step after the left hand side. Left hand side is this. I am writing its next step. Next step is this one. So cos C minus cos D is negative 2 sine of C plus D by 2. 3 pi by 4 plus x plus 3 pi by 4 minus x by 2 times sine C minus D by 2. Sine of, once again, C minus D. So here, because negative sign is there and two terms are coming up, both the terms signs will change. So I am writing this first. Sine C minus of D, sine C minus D. So D, here terms will change. This will become negative and the negative one will become positive. So sine C minus D by 2. So here x cancels, here 3 pi by 4 cancels. The next step, negative 2 sine 3 pi by 4 plus 3 pi by 4 is a twice of 3 pi by 4 divided by 2 sine of x plus x is a 2x by 2. What cancels? Let them cancel. Here negative 2 sine of 3 pi by 4 times sine x. So we have to get a value for sine 3 pi by 4 because x is a variable. We can't find its value. However, sine x is there in the right hand side. This one can be written in form of, first write pi by 4. And then here either pi or pi by 2. I see pi is better. So 4 into pi is 4 pi. 4 pi plus or minus pi should be 3 pi. So minus. So here 4 pi minus of pi is a 3 pi by 4. So 3 pi by 4 can be written in this form. Ultimately negative 2 sine of pi minus pi by 4. With respect to pi, sine remains sine. So I did not change this. Where is this angle? This angle is in pi minus pi by 4. It is in second quadrant. In second quadrant, sine and cosecant are positive. So sine of pi minus pi by 4 is positive sine of this angle, pi by 4. And then we have here sine x. Now negative 2. Sine pi by 4 is sine 45. Sine 45 is 1 upon root 2 sine x. The moment we get like this, irrational numbers in the denominator is not allowed. So we can multiply to the numerator and denominator by the rationalizing factor of this, that is root 2. Now negative 2 times root 2 is negative 2 root 2. Here sin x is there in the numerator. Denominator root 2 into root 2 is a 2. You can cancel this and we land at negative root 2 sin x, and this happens to be the right hand side. Now we have to prove that sine square 6x minus sine square 4x is a sine 2x times sine 10x. We will start from LHS and we'll go to RHS. Keep this in mind, when we prove trigonometric identities, there are so many ways of proving an identity, but I'm following one of the ways. Like, I will begin from left hand side. Left hand side is sine square 6x minus sine square 4x. Alright. Now, we know that the identity that sine A is a plus or minus root over of 1 minus cos 2A by 2. So, from here we will extract sine A expression. So, squaring on both sides, we will get sine square A, which is 1 minus cos 2A upon 2. So, first we will take A as 6x. For this expression, we will take A as 4x and we will write our two expression. So, when A is a 6x, cos twice 6x. When A is 4x, here cos 2 times 4x. Right. So, let's begin with this. Sine square 6x. Sine square 6x is 1 minus cos 2 times 6x by 2. 1 minus cos 2 times 6x divided by 2. Then the negative sign, and now this expression sine square 4x. Sine square 4x is 1 minus cos 2 times 4x by 2. 1 minus cos 2 times 4x by 2. Be careful, negative sign is there, two terms are there. So, the signs of this will change. Now, LCM of the denominator is a 2. And numerators 1 minus cos 12x minus 1 minus of minus plus cos 8x. 2 times 4x is 8x. What cancels? Let it cancel. Then these two will write in order, means a positive one first, negative one next. So we get in the numerator cos 8x minus cos 12x by 2. Now the numerator is in form of cos C minus cos D. Then we have the identity cos C minus cos D as negative 2 sine C plus D by 2 times sine C minus D by 2. So here 8x is C, 12x is D. The numerator is now twice negative 2 sine C plus D by 2, means 8x plus 12x by 2 times sine C minus D by 2, means 8x minus 12x by 2, and overall there is a 2. This 2 cancels, that's fine. Then negative of sine 8x plus 12x is 20x, 20x by 2 is a 10x times sine of 8x minus 12x. So 8 plus 4, so this is negative 4x by 2, which is ultimately negative 2x. Now the last but one step, negative sine 10x times sine of negative 2x. Sine is odd function, that is why sine of a negative angle is negative of sine of that angle. So this one is a negative sine 2x. Negative of negative is positive, and ultimately we can write plus sine 10x times sine 2x, sine 2x, and this is the right hand side. Sine 10x times sine 2x is the right hand side. So here we started from LHS and we came to the right hand side, hence the identity is proved. Now question number 14, we have to prove that sine 2x plus 2 sine 4x plus sine 6x is equal to 4 cos square x times sine 4x. We will begin from the complex part, that is left hand side, and we will come to right hand side. Left hand side, how to solve or how to simplify? So we have to assemble terms like sine 2x and sine 6x together, and this one as third term. So we will write this as sine 2x plus sine 6x plus twice sine 4x. Why did we do so? We did so that we can use some identity to simplify, because left hand side on simplification will come to right hand side. Now when we assemble these two together, this appears in form of sine c plus sine d. Sine c plus sine d is an identity which is twice sine c plus d by 2 times cos c minus d by 2. So this appears in form of 2 sine c plus d by 2 times cos c minus d by 2, plus the third term as it is 2 sine 4x. The next step, twice sine 2x plus 6x is 8x, 8x by 2 is 4x, cos 2x minus 6x is negative 4x, negative 4x by 2 is negative 2x, plus 2 sine 4x. Cos of negative, cos is even function, so this will be this will be positive of cos 2x. Now what is highest common factor in this expression? Highest common factor is 2 sine 4x, 2 sine 4x. We will take it as a common factor, 2 sine 4x, and then we begin the bracket. This is out, so what is left is cos 2x. Then there is plus, this term is out, so here 1. Now this will relate to some identity, 1 plus cos 2x. The identity is cos A is plus or minus root over of 1 plus cos 2a by 2. So we have that term 1 plus cos 2a. 1 plus cos 2a is here. So squaring on both sides, we get here cos square a, which is 1 plus cos 2a by 2. A simple cross multiplication will give us 2 cos square a is a 1 plus cos 2a. So what is a 1 plus cos 2x? It is a 2 cos square x. So this is 2 cos square x. Ultimately 2 into 2 is a 4 sine 4x times cos square x, and this happens to be the right hand side. We have 4 sine 4x times cos square x. 4 sine 4x times this, and this happens to be the right hand side, and hence the identity is proved. Now coming to 15th question, we have to prove that cot 4x times this expression is equal to cot x times this. So we can start from left hand side and we can reach to right hand side, or we can simplify left hand side, simplify right hand side. If the simplified forms are equal, then the identity is also true. Or we can rewrite this given equation like this divided by this and cot x by cot 4x, something like creating the left hand sides and right hand sides by using the like terms, and then using the formula sine c plus sine d, sine c minus sine d. So all of them are okay. So what I am doing is right now, so I'll simplify LHS, then I'll simplify RHS, and if the simplified result is same, then this identity is also true. Starting from left hand side, it is a cot 4x times sine 5x plus sine 3x. Cot 4x can be written as cos 4x upon sine 4x. Cot theta is cos theta by sine theta. Here sine c plus sine d. Sine c plus sine d is 2 sine c plus d by 2 times cos c minus d by 2. This one is cos 4x by sine 4x. Here twice sine 8x by 2, so 4x times cos 2x. 5x minus 3x is 2x. 2x by 2 is x. Now sine 4x cancels here. What we are left with is 2 cos x times cos 4x. This is a simplified form from left hand side. Now we'll take the right hand side. Right hand side is a cot x sine 5x sine 3x. So right hand side also we will simplify and we'll see whether we are getting the same term. Cot x is cos x by sin x. Sin c minus sin d. Sin c minus sin d is a twice cos of c plus d by 2 times sin of c minus d by 2. So we use the identity sin c minus sin d identity, which is 2 cos c plus d by 2 times sin c minus d by 2. So we have here cos x sin x, here twice cos 8x by 2 means 4x, sin 5x minus 3x is 2x. 2x by 2 is x. Sin x cancels here and we get twice cos x times cos 4x. Now just observe left hand side, right hand side condensed or simplified to the same thing. So we will give our conclusion. Since the right hand sides are equal, that would mean that the left hand sides are also equal. And what is left hand side? Left hand side is cot 4x times sin 5x plus sin 3x, and right hand side is cot x times sin 5x minus sin 3x, and hence this identity is proved. Now coming to 16th question, we have to prove that cos 9x minus cos 5x divided by sin 17x minus sin 3x is negative of sin 2x by cos x. This is a simple direct application of the identity cos c minus cos d and sin c minus sin d. We will begin from left hand side, but before writing the left hand side terms, I will write the identities which we are going to use. Since cos c minus cos d is negative 2 sin c plus d by 2 sin c minus d by 2 product form, and sin c minus sin d is a twice cos c plus d by 2 times sin c minus d by 2. So these two identities we are using in numerator and denominator. So begin with cos c minus cos d, which is going to be negative 2 sin c plus d by 2 times sin c minus d by 2 divided by sin c minus sin d, which is 2 cos c plus d by 2 times sin c minus d by 2. The 2's cancel, but the negative sign is still there. Negative of sin 9 plus 5 is 14. 14x by 2 is a 7x. Sin 9x minus 4x is 9x minus 5x is 4x. 4x by 2 is a 2x. Cos 17x plus 3x is 20x. 20x by 2 is 10x. Sin this is a 14x. 17 minus 3x is 14x by 2 is 7x. See if we have any cancellation. Yes. Then what we are left with is negative sin 2x by cos 10x, which happens to be the right hand side, and hence the identity is proved.